So 6.5 part 2, I split it in half. So this is on the back side of the 6.5 worksheet before. First question here, Rick needs $200,000 for his child's education in 18 years. If the account earns 4%, which is less than 5, right? It's not the best thing in the world, compounded quarterly, how much would he need to deposit now to reach his goal? First question, compound interest formula or PERT? Which one should we use? Compound interest, because they don't have what word in there? Continuously. What's different this time? What's different? What do we not know? The starting value. We don't know the starting value, which is called the principal, right? You know, do we know the ending value, though, in this case? Yep. So that actually goes in for A. You don't have to write this down, but here is the formula that we're using. Like I said, you don't need to write this part down, but isn't that the formula that we're using right here? We know A, so 200,000 is going to go in that. That's what Rick wants to have when we're all said and done. Then the principal, we don't know him, right? So he's just going to stay P. Is that cool in the gang right there? Then let's substitute all the other cool stuff in here. We got 1 plus our rate. Remember, we got to change it to a decimal. So what do you want to use for the rate? 0.04. Is that cool, yeah? N is the number of times we get interest. They use a word for us, you know, like quarterly, monthly, daily, weekly, semi-annually. What did they use in this case? Quarterly. So what are we going to use for our number? With that. Then it's going to be raised to the 4 time in years. How long is this going to be for? 18 years. So I'd just like to kind of tell you that 18 years, doesn't that make a lot of sense? If you just had a baby today, 18 years from now, shouldn't that child be 18 years old? And that's when they're like going off to college most likely in that era. That's why it's for like 18 years in that case. Let's do a little bit of figure, and let's figure that nugget out just like we did before. Let's do 4 times 18. I got 72. Are you cool with that? But here's the thing. We need to solve for P. And it looks ugly, and it actually is ugly, but it's really not that bad. See how this is all in parentheses? We're just going to think of that as just like one big red nugget right here. Don't cross it out, but see, that's just like a red nugget. You'll learn as you have me as a teacher, whenever we have stuff in parentheses, you just kind of like take a blind eye to what's in parentheses. Like, I can't really see it. Right here, isn't this red nugget to the 72nd power is what it's supposed to be, right? Times P. I would like to get P all by itself. There is a times red nugget to the 72nd power. How do you get rid of the multiplication in this? How do you get rid of multiplication? We are going to divide both sides by that red nugget. So over here, isn't there that 200,000 just sitting right there? I need to divide by that red nugget, which is 1 plus 0.04 over 4 in parentheses, right, to the 72nd power. And isn't that going to tell me what P is, right? So it looks messy, and it actually is harder to type in than you think. I would like to give you some advice of how to type this in, because there is a way to put that in. You got to be a parenthesis wizard to put it in the calculator properly, right? So there's easy ways and there's hard ways. Here's what I'd call the easy way. I want to figure out that denominator first. Are we cool with that? Just punch with me. Clear everything out of your calculator, but make sure we're putting that in parentheses. It's got to be the parenthesis 1 plus 0.04 divided by 4, close it up, and raise it. It was 72nd power. Was that correct? Was that the right exponent? To the 72nd power. Are you cool? It's just punching that in, right? Hit equals on it. You're going to get a nasty number. But here's how my trick works. We can never round that off. We have to use this number because it's what's this green guy down here. You can't even, some of you have learned how to like go up and copy numbers and paste them into other parts of your like equations that you want to do. You can't even copy and paste it because that decimal just keeps going, right? It's just a weird old decimal. Our calculator has rounded it off to like 8 decimal places, but it does keep going. So what I want to do is, don't I want to take 200,000 and divide it by that nasty number? There's an easy way to do it. You start by typing 200,000. And then you hit divided by, and there's no way I'm going to punch all those buttons in. That is a nonsense to try to retype those numbers. Somewhere on your calculator, you have a previous answer button. On the graphing calculators, it's right above the negative that says ANS. Yours is probably somewhere down by the equal sign down there also. Do you see an ANS in that scenario? So you got to hit second to get there, and then hit your previous answer. Maybe your math teachers in the past have showed you that. Maybe you've never seen that before, but previous answer is a lifesaver because it's the number from above that I don't want to copy down that's been like not rounded off. So bada boom. Are you cool with that? All right. So did we get this bad boy right here? Rick wants 200 grand in 18 years. He's got to save all this money right here, so we will do this. It's definitely $97,699, and let's talk about how many cents it should be. Do you want it to be 21 cents, or do you want it to be 22 cents? Well, we got lucky on this one because math rules say we're rounding it up to 22 cents, right? Here's the investment rule. You always have to round this up a penny. It doesn't matter if that says 0.21004, like the 21 cents is not enough, right? It has to go up. Would you believe that these extra decimals off to the side are trying to tell you you need more than 21 cents to make this work? So you will always have to round that up. An easier example is, let's say that we were like going to paint this room and we did all our calculations and it says that we need to get 3.4 gallons of paint. But we can't go to the store and buy 0.4 gallons of paint. I know you can buy quarts and things like that, but if you had to buy gallons, how many gallons of paint would you have to buy? 3 gallons or 4 gallons? You always have to round that up, right? Because 3.4 is not enough, right? So this 21 cents was not enough. Now, that's the true calculation. That's what homework will want also, the true calculation. But this is kind of dumb, right? If we were doing real life, I know that we're still a little too young for this, but there are people called financial advisors that where they'd go in and be like, hey man, I'd really like to have 200 grand for my kid's college in 18 years. How much should I invest now? The financial advisor would do the calculations. They'd get this number, and guess what people would probably do? They'd be like, oh, so I need to invest like $100,000. You know what I'm saying? It's like they'd probably round this, maybe even $98,000. You know, it's like I need $98,000. It's very rare that a person would say, oh, I need to invest $97,699.22. Let me just invest that right now. It's such a weird number. You know, it's not round, that they usually round it to at least the nearest $100, if not the nearest $1,000. You know, does that kind of make sense? It's like, hey, man, how much do I need? You know, but this is what we're putting into homework. Does that kind of make sense? That's the bare minimum. If this scenario was happening, we would get our 200 grand at the end. So, boom, that was a long-winded one for a pretty short day. Let's make it a little faster. Yolanda wants to have 15 grand saved in 5 years to make a down payment on a house. How much money should she invest now at this much interest? That's good interest, right? That's way more than 5. To compound monthly to meet her goal. It's all about, do we know the principle or do we need the principle? Are you with me on that? What do you think? Do we know the principle or do we need the principle? We need it, right? So that 15 grand is going to be at the end. It's going to equal our principal times our big old messy formula. And it's not going to be over 4 because they didn't say quarterly. Didn't they say monthly, right? So we're going over what number again? 12 to the 12 times time in years. They have to tell us that in the problem somewhere. Isn't it just 5 years, right? So again, if we figure this guy out ahead of time, this 12 times 5, that'll save us a little bit of a headache with parentheses and stuff like that. So 12 times 5 is 60. And then our final deal will be this, 15,000. We're just going to divide by this mess. That's going to equal P. And if we punch the denominator in first, it will really make life a lot easier. There are other ways to do it. It's just a bunch of messy parentheses. You also, when you punch this denominator in, you have to put that mess in parentheses. Otherwise, it's not going to work out right either. So you got to do that 1 plus 0.0625 divided by 12, and then raise that to the 60th. Like that's got to be in the parentheses. Cool? And you get a messy number. It's pretty much going to be messy like almost 100% of the time. It's very rarely going to come out nice. And then we take our amount that we wanted, that 15 grand, and divide it by that previous answer by using that ANS button. Like I said, on my calculator, it's right above the negative. And did you get this guy? So no matter what the weird decimal is at the end, we've always got to make it go up a penny. So it looks like 13 cents, it's got to be 14 cents. Even though the math rules are going to make it be 14 cents anyway, it's always, always, always got to go up, right? So 10,983.14 is what they got to invest. And if the financial advisor told you that, most people will go, cool, 11,000 bucks is what I got to put in the bank, right? You know, it's like it's almost 11,000 bucks, but it's $10,983.14. If you put that exact amount in, you would get your $15,000. If you put just $10,983 in, by the time this is expired, you would probably have like $14,997. You'd be close to $15,000, but you wouldn't quite get there in that case. So let's see if you can set this dude up. Why don't you pause the video and give it a shot. So there's what I got. I'm going to be honest with you. If you don't want to write that, if we do enough of these, you'll start figuring out, it's like, man, I'm just wasting a lot of time writing all this down. If you want to go straight to this purple stuff, it ain't going to hurt my feelings. I do at least need this purple thing written down. But the above step, if you did this 10 times in a row, you'd be like, you know what? It's always going to be the starting amount divided by that big old parenthesis thing. You know, it's like that's part of just doing things over and over and over again. You just got to know then how to punch it in. So 1 plus 0.07 divided by 2 raised to the 20th, bada boom, and then 20 grand divided by that. Things that I always double check, did I put enough zeros? Like when you type in 20 grand, it's like, did I put enough zeros? You know, that's the weird thing. Did you get $10,051? And what would you do, 31 cents or 32 cents? Yeah, regardless, all three of these, that's kind of bad on my part where the math rules would have made you round it up anyway. You've always, always, always got to round it up. So, cool. That's just how much do I need. Then we'll kind of switch gears into something that's actually, in my opinion, a little bit easier, just plain exponential growth and exponential decays. Let's just talk about those two formulas like before we do it. How do you know a guy is exponential growth? Megan Trainor tells us it's all about the base, right? What's true? What makes exponential growth exponential growth? Base is what? Bigger than 1. What's true about exponential decay? Base is between 0 and 1, right? So here's the true variable, time, isn't he, like up in the exponent. This is the base, but this is just like kind of like maybe some financial situations, but probably not. This is just about like population growth or like, I know you guys probably have not bought a vehicle in your life, but you need to understand this. If someone buys a brand new car today, 1 year from now, is it worth the same amount? Is it worth more or less? Less. It decays, right? It actually decays at an exponential rate. So like the next year it'll be worth even less than it was before. The year after that it'll be worth even less, right? It doesn't go down by the same amount every time. It goes down by a ratio usually. So exponential growth, exponential decay. One of the biggest exponential growths that's not financial is populations. So the estimated population of the world is increasing at an annual rate of, holy cow, difficult number to deal with, not even 8%. Are you with me on that? That is 0.8%, not even a percent. If in 2022, which it was because I looked this up, the population of the world was about 7.9 blah, 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 blah billion people, right, you know, predicted in 2026. Well, we've got this cool formula, which honestly, after we use them enough, you probably don't even need to memorize. It's just your amount's going to equal. This is still basically your principal, but it's not in a financial situation. It's just like your starting value, right? And then you just do like 1 plus your rate, you know, raised to the time in years power, right? It's a little easier in this case. So could you tell me this? What's the like principal? What's like the starting value? Obviously, it's not the starting value of the population of the world like in year 0. It's like when we started measuring this. Do we know a year when we started measuring this? 2022, right? Isn't it this big old honker number right here, right? So here's what it'll be. It'll be that big old guy. That's our principal. And then here's why I said that 0.8% is a hard one to deal with, because you got to move that decimal 2 places to the left, and it is amazing how many people would accidentally put 0.08 when it needs to be 0.008, right? This decimal has to move, boom, boom, 2 places to the left, to the 4th power. How did I get 4? I'm not trying to insult you, but like, it's time in years. If you started in 2022 and want to know in 2026, don't you just subtract those guys from each other, right? So it's been 4 years. Are we all good with that? And just punch that guy in. That's an easy one, right? Straight from left to right. So we're going to get big old number 7951 1 2 3 1 2 3. I still like to use parentheses. It just kind of makes sure things are good. To the 4th. Hey, should this number get bigger or smaller than the 7.9 billion? What do you think? Bigger or smaller? It's all about this base, right? Is this base bigger than 1? You bet. Not much, right? Not much bigger than 1 at all, but it is definitely bigger than 1, right? Exponential growth. Did you get that big old honker number? Write all those digits down, then go backwards every 3 spaces and put a comma, right? Every 3 digits, I should say, not every 3 spaces. Write all those numbers down, then put your comma back. And then we'll throw a label on that one of people. So if the growth rate stayed the same, we would expect next year, not this year, but next year, there to be about 8.2 billion people in the world. There's a bunch of questions on this on homework, so I'm just going to ask it again. Why is it exponential growth? How did you know? Base is bigger than 1, right? Are we okay? Base is bigger than 1. Next one. The town of Mulletville has been growing in recent years, but only in the back. The town of Mulletville has been growing in recent years, but only in the back. Mulletville, right? By roughly 9.8%. Do we not know what mullets are? Like they became popular in recent years. In 2018, there were this many people in Mulletville. How many should there be in 2025? Hey, exponential growth or exponential decay? There's a word in there that lets you know if it's going to be growing or decaying. What's the magic word? What do you got? How do you know? Oh, it says so. Cool. All right, so let's set it up. Let's set it up. The amount's going to equal our starting value. Well, obviously it's not when the town started. It's when we could start measuring it in 2018. And then tell me what's wrong with mine. Like, I'm going to figure out how many time in years. It started in 2018, and then we want to go to 2025, so don't you got to subtract those, right? You know? So that would be how many years? Sometimes it's nice to even write it down. T would equal what? From 2025 to 2018, that would be how many years? 7. Cool. Mine's wrong. That is wrong right there. What's wrong with that? I got my starting value, I got my rate, and I got my time in years as 7, right? What's wrong with it? I forgot to add the 1 to it, right? You know, isn't that part of the formula? That it's got to be 1 plus your rate in that case. Because that would be a really, really fast exponential decay in that case. That's not cool. But to make it exponential growth, it had to be bigger than 1, right? So then we can punch that guy in. Pretty basic. And I think we get a decimal on this. Is that right? Here's what we got to do. This is not money. Right? This is a different scenario. In this case, it's population. Sometimes it's not population, but we're going to round appropriately. Sometimes the homework will tell you how to round, and sometimes it won't. But I'm not going to put 19,692.65 people, right? You know, like if we were talking about people, what kind of number makes sense to round to? Whole numbers. So should it be 92 or 93? Honest answer, doesn't matter, right? It doesn't matter if you round it up or round it down. There's arguments for both. It's like, well, it's not quite all the way up to 93 people, right? You know, it's not enough yet, so we're going to make it go down to 92. Homework should probably accept either answer, if you did 92 or 93. I did 93 people. I just used math rules to do that. Is that okay? Notice I also put approximately instead of exactly, you know, because I rounded it. Both of those were exponential growth scenarios, right? Exponential growth. Why don't you read the next one and see if it is also exponential growth. What do you think? Growth or decay? There's a word in there that usually tells you. Probably decay. What's the magic word? Decreases. And this is where we're going to outsmart the formula. Sorry, I should have had it on this page, but we're going to do exponential decay. What's the difference between these two formulas? Only one minor difference. What's the difference? There's a minus, one minus the rate. Cool? So I'm going to do the first one the long way. We're going to start it out like this. The amount's going to equal, the starting value of this tractor was 45 grand, right? And then I'll put it all in there. 1 minus the rate. 12%, hey, there's a big one. You know, we've been dealing with the finances of like around 5%, 6%. This is not a financial situation. This is just a decay, so it's going to go to down by 0.12, and then they say 5 years. But here's where I'd like to outsmart this formula, because we are smart. There is nothing wrong with doing this. We can make it easy. Could you do me a favor and just like calculate that right there? What's 1 minus 0.12 going to be? What'd you get? 0.88, right? Now let's see if we can make any sense of that. What I would like us to get to eventually is to not have that first line ever written down. I'm going to ask different questions, see if it makes sense. Let's say there was a 10% chance of snow today. Do you know what chance it is that it doesn't snow today? If there's a 10% chance, what's the chance that it does not snow today? 90%, right? If there was a 25% chance of snow today, what's the chances that it does not snow today? 75%. If this dude loses 12% of its value every year, right? It's losing 12%. I'm asking you, how much does it keep? And it's right here. How much does it keep percent-wise? Doesn't it keep 88% of its value, right? If you lose 10% of your value, don't you still have 90% of your value? If you lose 25% of your value, don't you still have 75%? So I'm going to go back right here and maybe put a note to myself that says this dude right here is how much you keep. That 1 minus r is really how much you keep. And if you do 1 minus 12% or 100% minus 12%, aren't you always going to get 8% back? So if you want to just fast forward to this dude, you can get there. Hey, talk to me. How come this is exponential decay? Tell me about that base. Is it bigger than 1 or between 0 and 1? Isn't that going to be between 0 and 1, right? So this is going to go down. So let's do it. 45,000 times 0.88 to the fifth. Is that what it was, the fifth? More or less than 45,000 when I hit equals on this guy. I hope it's less. Isn't it supposed to go down, right? Did it go down a lot? I think it did, right? Now that tractor, when you bought it, was 45 grand. 5 years later, it's worth that much. Notice what I put in parentheses also. How should we round? I know we're still not the most experts on owning vehicles and buying vehicles. Have you ever seen a vehicle on a car lot or anything like that? Just go, what's the price of that vehicle? $23,747.94 is what we're going to charge you for that. Is that how car salesmen talk? How do you think we should round? There's more than one possible answer. What makes sense? Round into nearest what? Tens? So $23,750? Oh, tenths? Like $0.9? Nearest $100? So $23,800? $700? You know? Would that be okay around to the nearest 100? Have you ever seen a vehicle priced like that? It's like, hey, you know, $35,500. You know, it's like, that makes sense. What about to the nearest 1,000. What would that be to the nearest 1,000? 23,000 or 24,000, what would that be? 24,000 bucks, you know? To me, those are the two answers that make the most sense. Either rounding to the nearest $100 or the nearest $1,000. Does that kind of make sense? But it just got to let the scenario dictate. So whatever you'd like, right? I don't care. Let's do the nearest $100. The amount's going to be about, was it 23,000? What do you want, $700 or $800? They're both probably acceptable also, you know. Math rules say, like, sorry, I hit the wrong button. Shouldn't you round that down because the number to the right of the 7 is not a 5 or bigger, so about 700 bucks. If you have $800, that's fine also, but you got to think about how you want to round it. Cool? Read the next one, see if it's exponential growth or exponential decay. What do you want, exponential growth or exponential decay? What word tells you that what's the magic word in here? Depreciates. That's like the fancy word for it's going down, right? You know what I have forgotten to explain because I'm trying to do this fast, but it's not the fastest in the world, is how do you know it's exponential decay? I think everyone in here would know it is decay, right, because of the word depreciates, but how do you know it's not like linear, like going down by the same amount? What do they tell you it's depreciating by? A constant number or a percent? If it's depreciating or even growing by a percent, right, that's going to be the exponential situation, right? So because of the percent. So let's do it. The amount's going to be, what's the value of this machine when we started? 125,000. And then here's what I'd like to see if you can do. If you want to do 1 minus 0.15, you're welcome to. But if it's going to lose 15%, how much is it going to keep? And you still have to calculate it the same way, right? It's like if you're not sure if it's a weird number, you still got to do 1 minus 0.15. But if it's losing 15%, it is keeping how much? 85% of its value, right? And how long is this going to be? 10 years. Cool. I'll see if you can answer that. They even told you how to round. $125,000 machine. That's a lot of money if you don't know. 125,000 bucks is a lot. If you just had 125 bucks, you'd be very happy right now. It's like, look at this, you know. It's like $125,000 is extremely awesome. Times 0.85 to the 10th, is that right? Man, that machine costs $125,000. 10 years from now, it is only worth that. Boo, exponential decay. But they say round how? There's hundreds, so that means this dude right here, like this is the hundreds place. You look to the right of him. If he's 5 or larger, you round him up. If he's not, you round him down. So 24,600 to 24,700. 600, right? So nice. $24,600 approximately. Cool. All right. Make some quickers. I'll bet you would get all of these right, and we would probably get those either all right or all wrong. They ask you, hey man, what's the growth rate, what's the decay rate? First question, why in the world are they asking you, on these for the growth rate? What makes them growth? Base is bigger than 1. So you got to take the 1 away from it, right? You know, what is this guy growing by? Wouldn't that be the 0.48? Are you with me on that? But they want it as a percent, so what would that be? 48%. Next one, I'm going to go down, right, is 1.073. Take the 1 away from it, right, you know, because that'll find the rate, and change that guy to a percent. What's 0.073 change into percent? You move the decimal 2 places to the right is what you do. So what would that be? 7.3% growth rate. And then right here, this growth rate would, of course, be 12.3%. Are we good with that? Those are the easy ones. Over here on the decay, first can you recognize for me why they're decays? Because homework's going to ask you, is this growth or decay, growth or decay, growth or decay? Why are all these decays? Because that guy is between 0 and 1, right? But you know what's crazy? That's how much you keep, right? That's how much you keep. So isn't this right here keeping 91.2%? Are you with me on that? We got to do how much we lost, right? So if you do 1 minus this 0.912, then you got to change that to percent. Maybe you do 100 minus 91.2 is what you could do also, like if you change it to percent first. But didn't we just like lose 8.8% on this guy? How did I get that? I moved this decimal 2 places to the right. You're keeping 91.2%. Aren't we losing 8.8%? That is the decay rate. Make it a rounder number. If this was 0.90, you're keeping 90%. Aren't you losing 10% back in that case? So that's kind of the idea right here. So here, you are keeping 45%. You could do 100 minus 45 if you wanted to. Like if you change the first number into a percent before you start, it might be easier, you know. Aren't you losing 55%? And then here, they are keeping 1% of its value. What are you losing? 99%. Cool with decay rates. It's a little tricky.